Welcome, agents, to today's Critical Explainer. Your mission today is extracting maximum marks from a completely hostile exam paper. We are specifically targeting the Cambridge IGCSE Additional Mathematics 0606 exam, but honestly, these tactics apply whether your operation is code 0580, 4024, 4037, or 4040. The clock is ticking. Imagine this scenario. You're sitting in that exam hall, you have exactly 20 minutes left on the clock, the pressure is mounting, and you are staring down a highly complex, nonlinear data question. How do you extract every single possible mark before time runs out? To understand this, let's look at a real Cambridge mathematics past paper question. We have two agents in the field taking completely different approaches. First, there's Agent Alex. Alex absolutely overloads his paper with raw mathematical facts. It is a massive brain dump of every calculation he can think of. But there's zero analysis. There's no clear structure. It's just a chaotic mess of numbers. And because the examiner can't follow the logic, the red pen comes out. Marks are bleeding everywhere. Then we have Agent Sam. Sam looks at the clock, panics, and totally rushes the extraction. In the hurry, Sam completely misses the specific command word requirements, calculates the wrong gradient because the points chosen are too close together, and just completely skips the final evaluation step. More red ink. It's a disaster. But today, right now, we are going to change that. We are going to transform those red marks into green check marks and turn you into a master of exam extraction. Okay, let's dive right into why we are so focused on this. Converting nonlinear equations to straight-line forms accounts for an astonishing 15% of your total marks. Think about that for a second. 15%. Just mastering this one specific tactical maneuver, taking a curved, unpredictable set of data and forcing it into a straight, measurable line, can literally dictate whether you secure that A star or fall behind. In the grand scheme of the syllabus, 15% is a massive, highly valuable target. It is, without a doubt, the difference between a highly successful mission and total extraction failure. That's 2, maybe 3 entire grade boundaries hanging in the balance based on this one topic. We absolutely cannot afford to leave these marks on the table. You need a system, and that's exactly what we're going to build.
Here is your mission dossier for today's extraction. We're going to cover the 15% mission, cracking the code, the method mark strategy, deconstruct, solve, evaluate, and finally, evading examiner traps. Let's get into it.
Section 1, the 15% mission. Let's look at what Cambridge actually wants from you. The assessment framework demands way more than just rote memorization. Top-performing candidates exhibit a connected understanding that they can instantly adapt to completely unfamiliar operational contexts. The examiners, they aren't just looking for human calculators. If they wanted a calculator, they wouldn't test you. They are looking for analytical depth and clear, logical reasoning. This is where you need to apply the Peel framework. You might know Peel from writing essays in English or history, but I'm telling you, it is a secret weapon in mathematics. Point, evidence, explanation, link. When you're tackling a straight-line graph question, your point is identifying the correct linear equation format. Your evidence is the extracted data points you pull from the table or graph. Your explanation is your systematic step-by-step calculation of the gradient and the y-intercept. And crucially, your link is tying those calculated values back to the original unknown constants the question asked for. When we look at Agent Alex's messy answer versus a top-tier answer, the winning one correctly follows this Peel framework. It doesn't just show numbers, it clearly links the mathematical process back to the original context of the question.
Moving to Section 2, cracking the code. It's time to deal with those straight-line forms. In the field, you must know how to transform complex nonlinear relationships into their linear counterparts to effectively extract data. I like to call these nonlinear equations enemy codes. Let's decrypt the first enemy code. Y equals a times x to the power of n. If you plot this directly, it's a curve. It's totally useless to us for extracting simple constants. We need the universal straight line code, which we all know is y equals mx plus c. So what is our tactical move here? We take the logarithm of both sides. By using the laws of logarithms, multiplication becomes addition, and that exponent drops down. This transforms the equation into log y equals log a plus n times log x. Boom, the code is completely cracked. Now look at the alignment. Your log y is your large y-axis variable. Your log x is your large x-axis variable. The gradient, m, is strictly equal to that power, n. And the y-intercept, c, is exactly equal to log a. Let's look at the second code they'll throw at you. Y equals a times b to the power of x. Take logs again. We get log y equals log a plus x times log b. This time, our y-axis is log y, our x-axis is just plain x, our gradient is log b, and our y-intercept is log a. By mapping these nonlinear variables directly to the y equals mx plus c skeleton, those confused red scribbles from Agent Alex are instantly transformed into a methodical green-checked mathematics success blueprint.
Now, examiners love to escalate the threat level and throw advanced codes at you. But don't panic, the system holds up. Let's break down some complex forms. Take the first one, y squared equals a times x cubed plus b. How on earth do we make this a straight line? It's simpler than it looks. Your large y is just y squared. Your large x is x cubed. Treat them as single, solid blocks of data. Your gradient is a, and your intercept is b. Look at the second one, e to the power of 2x equals a times x squared plus b. It looks absolutely terrifying, right? But it's the exact same blueprint. Your y-axis variable is the entire term, e to the power of 2x. Your x-axis variable is x squared. The gradient is a, the intercept is b. And the third one, y cubed equals a times the natural log of x plus b. Y-axis is y cubed, x-axis is ln x, gradient is a, intercept is b. Listen, if you can visually map any wild complex equation they give you onto the simple skeleton of y equals mx plus c, you have completely neutralized the threat. You control the math doesn't control you.
Let's move to Section 3, the method mark strategy. This is how you secure your points no matter what. You need to understand the method mark strategy. It's essentially your exam insurance policy. If you show a systematic sequence, identifying key elements, applying relevant principles, and using clear notation, you secure valuable method marks even if things go wrong at the end. Let's say you successfully decrypt the equation, you plot the points beautifully, you draw a brilliant line of best fit, and you set up your gradient calculation perfectly with rise over run. But under the intense pressure of the exam extraction, with the clock ticking down, your finger slips. You type one number wrong into your calculator. Your final gradient is slightly off. Do you lose all 15 marks? Absolutely not. Because the examiners use the method mark strategy. They award points for the process, not just the final destination. They give you a mark for stating the correct log equation, a mark for creating a table of correctly calculated log values, a mark for plotting them accurately on the grid, a mark for drawing a sensible line of best fit, a mark for clearly showing the gradient calculation coordinates. You can easily extract 80 to 90% of the marks on a question, even if your final line of code has a tiny bug in it, provided your logic is flawlessly displayed on the page.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Consistent practice is your greatest asset in the field, so join the team and let's lock down those grades.
Section 4, Deconstruct, Solve, Evaluate. This is the active workshop phase of our mission.
Let's break down the ultimate tactical gear for your exam extraction. I want you to imagine a 60-second timer ticking down on your screen right now. We're doing a data scan. First up, deconstruct. You stare at a complex data table. You have to identify the given information and extract the core trend immediately. If your y values multiply by a constant factor for every regular addition in x, your brain should instantly scream exponential code. Next up, challenge 2, solve. Imagine a flawed sample paragraph from Agent Sam. Where's the flaw? Sam didn't solve systematically with clear mathematical notation. If you plot log y against x, make sure you know exactly what your gradient represents. In that specific case, the gradient is log b, it is not just a. If you mix those up, the system collapses. Finally, challenge 3, evaluate. This is speed writing. You have 30 seconds to write one perfect PEL paragraph. You have to check your answers for reasonableness and justify any conclusions with hard evidence. A perfect execution means you explicitly set your intercept equal to log A, you carefully read the axis value, and you correctly calculate the final constant showing every single step. Follow these 3 phases, deconstruct, solve, evaluate, and your extraction will be flawless.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Now on to Section 5, Evading Examiner Traps.
We need to talk about survival in the field. What are the critical failures that cause students their grades during these high-stakes exam missions? Why do so many agents get caught in the snare? I'll tell you a secret. It is almost never a lack of pure mathematical knowledge. It's a failure of execution. It's stepping on the exact same landmines year after year after year. So let's consult the classified intelligence from actual Cambridge Principal Examiner reports.
Examiners explicitly warn us about these top 3 mistakes. Trap number 1.
vague answers. Listen, you cannot just draw a line of best fit freehand that curves like a banana, pick two random points that aren't even sitting on the line you drew, and just guess the gradient. That's what Agent Sam did, and it's a critical fail. Examiners demand specific, rigorous details. You must draw a sharp, single straight line with a ruler. You must clearly mark the points you use for your gradient calculation with a visible cross or circle, and those points must be far apart on the line to ensure accuracy. Trap number 2, incorrect format and presentation. This sounds minor, but it is lethal. This means forgetting your axes labels. If you converted x to log x to make your straight line, your axis must be explicitly labeled log x. If you just casually label it x, the examiner assumes you don't understand the transformation, and you lose the mark instantly. Trap number 3, generic answers. This is the classic mistake. If the question specifically asks you to find the initial population size P0, and you do all the math, find the y-intercept, write c = 4, and just leave it there, you fail the objective. You haven't linked it back. You must explicitly state, therefore, the initial population P0 = 10 to the power 4. You have to link your math back to the reality of the question. To truly master this extraction and guarantee top marks, you have to embrace this mindset. Top candidates compare approaches, identify similarities and differences, and back up every single claim with evidence. Your complete mathematics answering system relies on 3 golden rules to reach a 100% mark potential. Rule 1. Command word decoding. You must know exactly what calculate, plot, and evaluate mean in the context of straight-line graphs, and deliver exactly what is asked. Rule 2. Peel framework application. Always structure your written justifications clearly. Point, evidence, explanation, link. Rule 3. The time management matrix. This is crucial. Don't spend 15 minutes sweating over perfectly aligning a ruler to get the absolute ultimate line of best fit. Spend 2 minutes plotting, 1 minute drawing a sensible, highly accurate line, and invest the rest of your time securing your method marks with clear, step-by-step algebraic manipulation. That is how you reach 100% extraction efficiency without running out of time. You've got the intelligence, now you need the reps. Remember to practice these straight-line concepts on actual past papers. Treat every single practice session with the exact same intensity as the real exaction. Listen to me. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So, agents, I have a question for you. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing with these nonlinear extractions. Is it the logarithms, the line of best fit? Let me know. Our team responds to every comment. Like and share this video with a study partner who needs this intelligence. Ace the Exams, your Cambridge success starts here. Dismissed, agents. Let's get to work.